Okay, again. J means rotate 90 degrees. Okay, this is the real. You rotate 90 degrees, you get J. Another 90 degrees, you go back to the real. And another one, and now you get a minus J. Okay, so J basically it rotate 90 degrees. And we learning the complex number using to solving the RCL circuit. Okay, and in the complex number, you can get the one coordinate for the rectangular coordinate and the phasor coordinate, and you have to get through that. Okay, for example, you can see A will be C cosine theta and B will be C sine theta, and the C will be square root of A square, B square, and the theta will be arctan B divide A. That's what we already did yesterday. You converting from rectangular to the phasor. And also they already telling you in a complex number, if you want to add two numbers or minus subtract two numbers using rectangular. If you want to multiply or divide it, then you have to be using phasor. So you have to understand from one to the other coordinate, you must know how to change it, okay? That's what we already did yesterday, okay? That's what we don't care much, okay? So you can say in the example here, they given you A and B, and they want to adding A to B or subtraction, and we already did it, okay? Or they want to using the multiplication or division. You have to using the polar, okay? So that is very important. Up to that point, you get any question? Make sure that must be clear to you. Later on, will be more easy to solving the circuitry for RCL. That we already done. Now we start here. That's the RC circuit. Before we try to do anything, I want to make sure you understand this thing. I try to see the relation between resistor, inductor reactance XL, and capacity reactance. Okay, I see. First thing, XL vector will be go this way. Sorry, that will be The thing is register have a no phase difference. Okay. How I draw XL? If I want to draw for XL, how can we do it? Go right or left or up or down?
Wouldn't XL be up since inductance is above the x-axis in a positive direction, and XC would be down because it's below the x-axis?
That's what you have to understand. For the capacitor, current IC leading VC 90 degrees. For the inductor, VL leading IL 90 degrees. And there you will be telling you IL and XC always opposite 180 degrees of phase. Okay. HL and IC 180 degrees of phase. All the time, XL will be go up and XC will be going down. Okay. So now in this circuitry here, we already did it. Okay. We already did it. Now we're going to do it with a different way, using the complex number. First thing, in order to do using the complex number and make sure XC must be changed to Z. XC equal 80 ohm. Then now they have to be Z 80 ohm. And they have to be minus the thing that they're going down. So first thing, you need to change that one. Minus J 80. That's just the way how to solving the problem. And now they want the total G impedance. So can you tell me what total impedance?
So, Mr. Pham, so would you write that as 60 minus J80, and then for ZT, you would put the square root of 60 squared plus 80 squared, or is that minus plus or minus 80 squared?
Okay, first thing you want to calculate the total impedance. Then you can using R plus J. Okay, the thing is you're using the complex number. Okay, so G total equal R. That means 60 minus J 80.
Right.
So basically, that will be in the complex number. So if you want to calculate the total resistance, then you understand the GT will be equal what?
60 squared minus 80 squared, and then take the square root.
G total equals square root of A square plus B square, right?
Right.
Okay, so you need to do it. And you let me know what you get.
Hey, Mr. Pham, can I ask you a question?
Go ahead.
For the 80, should it be plus a minus 80 squared? Since it's a capacitor?
That's what I said. Capacitor, when you change to the complex, they must be minus J. For the inductor, they will be plus J. J going up. For
My question was, when you put it in the square root, do you put plus a minus 80 squared, or you don't need to put the minus in there?
That's a difference. If you're looking into the formula, you see that?
Right.
C equals square root A square plus B square.
But B is 80, and in this case, 80 is minus J. That's what I'm asking.
That's a minus for J, not for 80.
Okay, all right, okay.
Go ahead and calculate, telling me what you get. So I can tell you exactly the value supposed to be.
It should be 100.
Perfect. That is correct. The answer will be 100 ohm. Okay. Now, second, they want to calculate the total current. I total equals V total divide G total. Okay, so we already telling you, if you want to multiply or divide it, they will be in phasor, not rectangular. So you have to change the G total into the phasor. So I want G total $60 minus J80. And I want it in phasor. Can you do that for me? That means you have to get the amplitude and the phase angle. So if you get it, let me know. Okay. However you get it, please let me know. Make sure you know how to convert it from the rectangular into the phasor.
Is it 100 and then 53 degree?
100, right?
Yeah, 53 degree.
Angle 63.
53.
Oh, 53. Okay, make sure everyone able to get that answer.
It'd be a negative 53 degrees.
Minus 53, right?
Yes.
Okay, so you get that active in phasor.
Hey, Mr. Pham, so, and the reason it's a minus 53 is because the capacitor is below the x-axis, correct?
I see. Going down.
Right, so it's that's the reason the angle is negative, because XC is below the x-axis.
You look
Right.
at it's negative J. So negative J, it should be pointing down.
Okay, yeah, thanks, Sam, thank you.
Yeah, you have to draw the phasor, then you know the angle. I can try to repeat that for you right here. You can see that one. Real. So basically that is R. And that will be HC.
XC, okay, there you go.
Okay. Then you have to draw phasor. Okay. You draw R first and HC going down. And that given you the angle right here. The angle already get the formula to calculate. That will be R10 of
Correct.
minus HC over R.
Thank you, Mr. Sam and Sam. That makes sense. Yeah, got it.
Okay, good.
The thing is, you have to follow that. Now, I total equal V total is 100 volt. So basically, they're not telling you any phase. So basically, 100 angle will be 0. Divide to G total. G total also 100, right? Angle will be minus 53, correct?
Correct.
So what the total current?
It's 1 at an angle of plus 53 degrees.
And Mr. Pham, do we assume that these are amps, the units here?
Can you say again?
Do we assume that the units here is 1 amp and at 53 degrees?
Yeah, 1 amp and 50 degrees. So basically the answer If they asking only the value of the current, then you say 1 amp. But the calculation that given to you, they get a 50 degree for the current. Okay. The next will be calculate the VR equal I total time R. See what you get. I total time R.
So this 60 also 60 volts at an angle of phase of 53.
Okay. You multiply, you have to using phasor. Okay. I total will be 1 angle 53. R will be 60. Angle will be 0. Okay. So you can get the 60 volt IMS and the angle will be add them up. Okay. So they will be I will be 1 times 60. You get 60 volt. Okay. If you want the angle, they will be angle 53. VC. I total time HC. So 153. Time XC. What XC you get?
80 at minus 90 degrees. So you get 80 for the magnitude, and then you, for the degrees, is 90 minus 90 plus 53.
So you get minus what degree?
Minus 37.
So you want the value. They will be 80 volt. Last one. Okay, someone asking for how come using calculator you get 53 degrees. And
Yeah.
happen.
Yeah, they're in some set, right? Make sure the calculator's in degree mode and not in radian mode. If it's in radian mode, it's not going to give you the degrees.
So how do I change that? I see the rad on the top left corner.
what kind of calculator you're using.
From the, oh wait, okay, I see a degree button. Let me see.
Yeah, so
Okay, I found it. Got it.
Okay.
Okay, I'm using the iPhone calculator.
yeah, if you use
Okay.
the one on your computer, you should be, depending on what calculator you use on your phone, on your computer. So yeah, so okay, you found the right mode.
So it
Okay.
should be 80 divided by 60 gives me 1.33. And then I do second tangent, not tangent. And okay, got it. Thank you. Found it.
Okay,
Excellent. Beautiful.
all right.
Stuck on that.
Okay, last one. What the phase angle between the total voltage and the total current. What degree?
Degrees, 90.
What do you mean 90?
Yeah, well, one is 53, the other is minus 37. Isn't the difference between the two 90?
No. You understand in the circuitry, you know VC, IC leading VC 90. R will be no phase. Only the total voltage and the total current. They're not leading or lagging 90 degrees. They're not in phase. They get a different phase. That's why we need to calculate it. Okay? In the past, we already know for RC. Then you know how to calculate it. Like theta equal arc10 of minus HC over R. However, if you're using the complex number, then just look into the one we already calculated. IT. That one here. 1 ampere and the phase 53 degrees. Okay. And also, let's see which one we can get.
VT is 100 at 0 degrees.
What do you mean? Is IC or what?
The question 5 says the phase angle between VT and IT. So IT is 1 at 53 and VT is 100 at 0 degrees.
No. If you calculate it in the past, equal 10 minus 1. I believe HC over R. Substitute into calculate it for me.
Negative 53.
Negative 53. Okay. Now, when you're looking in the IT, okay, and you get a 1 amp, and the phase will be 53 degrees. So basically, IT, okay, different with the VT will be 53 degrees. However, the minus side, they're telling you, let's say, VT will be leading. Okay, now we'll see in here. On this circuitry here, the current I total, I total equal I R equal I C. That's correct for series. And you know IC leading. VC 90 degrees. That's correct.
Right, for a capacitor, the current leads the voltage by 90 degrees, correct.
Okay. IC, go ahead.
Now, I was just going to say, what I'm trying to understand, and I guess the students are too, Mr. Pham, the question itself says, what basically, what is the phase angle between VT and IT?
Okay, that's what I try to explain to you. Okay. First thing is you try to understand on the thing we already did it before you can apply into the complex number. If you're looking into complex number here, then you can try to see, okay, how come you can get minus 53?
Is it possible that you could use the XY coordinates and draw it on your iPad so we can see it, so we can visually see it?
Okay, that's what, if you want to draw that, right?
Yeah, do it on your coordinates.
Okay. So now, which one you want that to be here?
BT.
VT, they get a phase different. You cannot draw that. This one will be for zero phase. No phase.
But isn't VT 100 at 0 degrees?
Now, how come you get 100 degrees?
Because that's what we get, because IT is equal to VT over ZT. And in that formula, we got VT is equal to 100 at 0 degrees. That's where I got it from.
VT and IT get a different phase.
I understand that.
And you cannot say 100. My question is, if you want to draw the phasor, okay, this is the real. So what I asking you, I draw the vector here, stand for what? What you want?
0 degrees is really supposed to be 90 degrees on the x-axis.
Yeah, I don't care for now. I care about what telling me what vector here for which one.
The vector is, the, what's it called?
Imaginary vertical.
One second. You're referring to the value.
No, it's not a value.
It-
Let's deal with the phase. Which one has a no phase in here?
The resistor R.
R, that's a 1. VR or IR, right? Resistor have a no phase. So if you want to draw for the resistor, capacitor, inductor, you draw that R. However, if you want to draw for the current, IR, then this must be IR. And IR also the same with the IT, correct? IT, IR, IC. That's the
Correct.
only one current.
Oh, yeah, because current is the same in a series circuit.
So that's why you draw IR. A lot of students could understand how come we draw for R, or we draw for V, or we draw for I. So in this case, I want to draw for IT. And I know IT, IR will be the same. So that's why I have to draw IR. And also that will be IT. You get that?
Yeah, I get that part of it. Now, where's VT at on this?
That's
On-
what now. Next one you need to draw for VT. So if you want to draw for VT, you need to draw for VC or IC, right?
Do we use the voltage divider rule for VC? Meaning 80 times 60 divided by 80 plus 60?
Okay, now you get IC lead VC 90. Okay. And that will be telling you IR leading VC 90 degree, correct? Or I can say IT lead VC 90 degrees. Now, I get the IR. I want the IC. How do we draw IC? This is IR.
Is it gonna look the same? Like as our IR is equal to IC, so it's gonna look the same vector,
The same vector, but the phase different.
but the phase is different. So it's gonna be up a little,
Up, right?
up.
And now when you connect that one here,
Right.
okay, you can see, you can draw that one is IR. IC. And that I total. And that's the phase angle. Okay. And I phase angle is positive. That means the IT will be leading VT 53 degrees. Okay. However, in order to easy for you, when you want to see on the series, see the phase right here. Minus 53. That's the answer. Can you solve this for me quickly? Hopefully they will be much more clear for you. Now it's still series, but RL. First thing, you get the Z total. And you already know XL40 will be changed to Z40.
30 plus J40.
So you can get R plus JXL, or you can get 30
plus
plus J40. You want the value. Go into calculate. Remember, square root a squared plus
$50.
what you get? 50 ohm, all right? Okay, then you can calculate the I total. Z total. Z total. Okay. V total will be 50 angle 0. Z total. Z total must be converting into the polar.
50 with 53.
Now, Z total, okay, you can get 50 angle will be 40 divided 50, right? What the angle?
Is it 53.1
53.
or something? 53,
13.
right.
Okay, so divide 50 angle, okay, will be 53. 13. So what you get? 1 amp.
1 and
At minus.
minus. Yeah.
VR. I'm not doing calculation. I just want to give you the answer. VR VC. And phase.
30,
VR equal
30 with minus
30 volt, right? Did you get 30 volt? Whatever angle, we don't care.
okay.
BC,
BL
what you get?
This has an inductor, so how could you get VC?
yeah, it's
BL,
yeah.
BL.
40, yeah.
Forty.
40, correct.
And Mr. Pham, would that be like 40 at,
Okay.
would that be 40 at plus 90 degrees?
I don't know. I don't care for now. Nobody asking that phase.
Phrases.
The answer for the phase angle.
Can see.
53.13.
That's what I'm already telling you. Phase angle right here,
This is
5313.
53.1.
So basically, if you're using the complex number, easy to get it through quickly. However, make sure you know how to convert between the rectangular into the polar. Okay? Any question on this example? The purpose of the complex number will be using to solving RCL circuitry, either parallel or series. Now, you do it for me. This circuitry, you already did it, but we want it to be done by complex number. I already telling you. For inductor, IKL 40, J to J 40. If the capacitor will be minus J, that's just a formula. So who will get the I R?
0.4.
IR 0.4 amp.
0.4. Okay.
Or 400 milliamp. IL
0.3.
yeah, 0.3 or 300 milliamp. I total.
One five.
Okay, now you can calculate the I total. Will be V total.
0.5.
You get a 0.5. That's the correct. Okay. Y total. Okay, G total equal how many O?
24.
Exactly.
84. The 24. Oh yeah. That's up.
Fair.
17, 18, 17, 18. 0.5. $90.
At negative 90 degrees with phase angle.
30.13.
Okay, you get 30. I get a wrong one. So you have to tell me different.
Zero. Yeah, 36.8. Yeah.
If you're doing calculate, I want the data telling me what the angle.
36.8.
Okay,
Right.
36.8.
86.
Okay, that will be correct. So the phase, okay, basically they will be minus 36.8 degrees. Okay, so let's see how many more. 1, 2, 3. Okay, 3 more. Try to working on that. Okay, next meeting we will quickly done. That will be calculated for RC parallel, RCL series, and RCL parallel. Thinking I get a 30 more minutes, I will be given a lecture for anyone, new student, not get along with the oscilloscope. Okay, then I try to make sure they know how to use it, working on the digital scope in the lab right now. Okay, and also make sure you need to download the handout, okay, for how to use it. Oscilloscope. If you don't need it, then you don't care, okay? However, any student want to learn about oscilloscope, okay? I suppose to get a quiz, but we can delay that for next week. Okay, any question up to this point?
Yes, can you, the phase angle for the reason why it was negative 36.8 is because the capacitor is leading the resistor. And that's why we say when we solved for the phase angle for IT total, we got 3686 degrees. But then the phase angle for ZT is
That means
negative.
you get the I total, right?
Right,
Okay, they get positive.
is positive.
Yeah. So basically, that will be telling you the phase difference.
It-
Will be either they can be positive or negative.
Okay,
However, which one will be leading?
the capacitor is leading.
V total.
The,
The thing is 36.8. That's the phase between V total. Okay, and I total.
correct,
V, that is series or parallel.
parallel,
Parallel, that means
1 over
V total and VC will be the same phase,
V total will be the same phase.
Right?
Yeah,
only
right,
one V.
correct.
Okay, so IC leading VC 90. So they will be, IC also will be leading VT 90.
It'll run out by itself.
Okay,
So I'm not gonna shut it off, but it'll run off by itself.
Michael, mute your mic, your mic.
Oops, sorry.
okay, that is a handout. You need to download it from the handout. That's what I give it. And you need it, you can just bring it out. Okay, bring it out every time you do it. Just open the handout where we help you. So basically, this is a digital scope using in the lab. And also you understand you get a two different scope. One we call an analog scope and a digital scope. They working the same. Okay. And you understand the oscilloscope is a time domain. If you're using the analog scope, you cannot measure the frequency. The thing is time domain. Only thing you can measure will be a period, T. Then you have to using the formula, F over T, to calculate the frequency. And also, if you want the VIMS, you have to measure the V peak, then using the formula to converting to V IMF. The digital will be doing better. That means if you want frequency, they given to you frequency. You want VIMF, they given you IMF and something else. So the cost will be cost more than analog scope, okay? And that one also you can use it at an analog scope, no big deal. However, you need to know how to working with that. So in here, you can see how many windows, okay? Normally you can get 1, 2, 3, 4 windows. So the first thing, you have to set it up the window. For first window, we'll be working for which channel. You see here, you get channel 1 and channel 2. So normally, you can set first window for channel 1, second for channel 1. The next will be channel 2 and channel 2. Okay? And also, that is you set it up for each channel. How to do it? They will be telling you in here. Set each window to design channel. First thing you need to press the button, auto set, then measure. Then you can press the top button, 5 from bottom, select the source. Then you press each button to change the window to design channel. You want channel 1 or want channel 2. Okay? And then the next step for first window, what you want to measure. You say, okay, I want to measure frequency. Then you have to do a press the sword here, change to the type. What type you want? I want measure for frequency, peak to peak. Next one to be frequency for channel 1. And whatever for channel 2, you can do it. Okay? Then, the very important thing, okay? If you want to see detail in here, so you can see it right here. They say channel 1, 500 millivolt per division. Okay, you can see they get how many division. Okay, you can count. I believe 8 division total. And the next here show you what? Channel 2, 10 millivolt per division. And the next here show 5 millisecond per time division. That means they're telling you how to read that one. Okay? But the important thing, when you connect the scope probe here, this is the scope, okay? Scope probe. You can see, you can connect this side, must be connected to the right. And this will be connected to where you want to measure. However, when your scope probe, they can set by 1 or by 10, okay? That means you must be set for the scope probe for channel 1 of the scope by 1, the same with the scope probe. You 1 by 10, that be fine, no big deal. But they must be matching. Okay? And now you can see here. They already telling you how to set window to design measure. Okay? Set scope probe matching. Press channel 1 menu or channel 2. On the probe window, press the button to change to 1x or 10x, depend on your scope probe. Okay? And also they're telling you how to set the channel to AC or DC coupling. Now, you have to understand, if you set to DC coupling, what happened? Who tell me? If I set to DC coupling, so what happened display on the oscilloscope? Who can answer me? If I set the scope to DC coupling, so what happened display on the oscilloscope? If you are already working on the oscilloscope, you're supposed to let me know. No answer at all? Okay. When you set the scope to DC coupling, on the oscilloscope, they will be display both signal, DC and AC. Okay? Then what happens if you set it to AC coupling?
It will only show AC, not the
They
DC.
show AC only. The thing is, sometimes you can see, you get a very small AC signal. At a certain point, you can also get a DC voltage. If you set DC coupling, you cannot measure the AC. So that's why you must set that to AC coupling. So scope will be blocking DC. So we can measure the AC. That is the purpose. To get the measurement, press auto set, then measure, and read the value. Okay, so basically, you want frequency, you can get a frequency. You want V peak to peak, you can get a V peak to peak. If you want VIMF, you set to measure VIMF, you get it. Okay, you don't have to do any calculation. And the question is, when do we need we need to press auto set, then measure. You're already working on oscilloscope, this oscilloscope. My question is, when do we need to press auto set, then measure? Okay, so basically, nobody answer me, okay? I can tell you, every time you change the signal, okay? Or you want to measure different point in your circuitry. So you need to press auto set, then measure. So the scope can be updated to the new data. Okay, and a lot of things will be happen. We don't have enough time. And now I will be show you the real, okay, the real scope. And show you what can we do. Okay, so now you can see this is the generator. And this is the oscilloscope right here. Okay, so basically they display the sideways. If you want to see the value, okay, you can see a window here. Okay, I can so try to see, we can get it bigger or better look into that. Now, if I press auto set measure, you can see what happened. The value still be the same. However, they display how many cycles? 1, 2, 3, 4, almost 5. But I only want only 2 cycles. What can we do? This will be telling you, changing this button here. Okay. You see that? Now,
What was the name of that button? that you
okay,
put?
you can see in here.
It's hard to see the name of it.
Okay, if you see the real one, okay. Second division. You understand time domain. That will be the time. Okay. And also in here, they can tell you how many? 25 milliseconds. I think so. Okay. When you're working on, you can see on the signal on the generator and the scope, you can recognize that. Now, if I change that one, okay, frequency to 10 kilohertz. Right now, I'm not talking more about generator next time. Right now, you can see 1 kilohertz. If you read in here, they said frequency 1.01 kilohertz. Okay, I change it to 10 kilohertz. See that? When you change to the 1 kilohertz, and you cannot recognize it. So what I telling you, you must be press auto set, then measure. Okay, and now you can see, but if you want to make it not too much cycle, you can change second per division here. Okay, and if you're looking on the scope display, they say 10.2, okay, kilohertz. If I say, okay, now I want only 5 kilohertz, what can we do? I want 5 kilohertz signal.
Decrease it from the function generator.
Exactly. You can see your function generator here. That is the range. That's telling you you set to a 10 kilohertz. That means the signal can go from 0 to 10 kilohertz. If you put it in a 1 kilohertz, you know where you can get a 5 kilohertz. And after you get maximum is 10, you can change that one. Did not here to 5. You can see I can change that. Okay. Going down. Okay, to 5 kilohertz. Then you need to press auto set, measure. Okay. And if you're looking into the window, channel 1 frequency will be for 5.0, whatever number. Okay. And if you want look it better, change the second per division here. Okay. That will be much, much better.
Hey, Mr. Pham, I don't want to get into something too big. Can you explain the concept of the trigger? The trigger?
What do you mean trigger?
The trigger on the scope.
Which one? Which button?
The trigger.
Yeah. I'm talking about the scope. If you get question on the scope, then I can explain to you. This is too general. Okay, a lot of things have to get into the scope, but the basic thing you must get through. You know they get two channels, channel 1, channel 2. And also this scope get a 4 window. You have to know which window to be set using for channel 1 or channel 2. And each window, how to set what you want to measure. V-peak, two-peak, VIMS, whatever, frequency or period, then you have to know. Also, the relation between the scope probe and the probe on the scope set the same by 1 or by 10. So that's why when you're working on that, I on the lab, still confusing, you can ask me. but have to be no problem. You get along with one oscilloscope, you can do apply for any different. Basically, they get 2 channels. Sometimes they get 4 channels. Okay? But doesn't matter. If you want to doing like analog scope, okay, that means you're able to set channel 1 here to any voltage you want. Okay? So if you tap into that one, that means you not automatically tell the computer do. The oscilloscope do for you. Do the thing that you want by hand. So you want the voltage, you have to count, see how many division. Each division will be how many volts. For this scope, you want scope doing everything for you. Okay? And you don't need to do anything. Set it up or for channel 1 and channel 2. Okay? The thing is what we have to do to help you. First thing, I guarantee you understand how to working on oscilloscope. Second thing, how do we do in order to get the signal from the generator the way we want. Okay? After we done, then I will be go into the left phone circuit board. Not everything, but I will be pick it up. Some you never know. Some you will get a problem. For example, when you measure the phase difference, how do we measure the phase difference? Or how do we measure the voltage across 2 points? Like you want to measure from point A to point B. How can we do it? The thing is you already working on the oscilloscope. If I asking you and you can telling me, if I want to measure the voltage, not with the round, voltage from A to B, how can we do? The thing is when you're using the scope channel 1, you connect to point A. And the other of the scope channel 1 must be connected to the route. That only telling you you measure at voltage at point A, not from A to B. Then now you have to using channel 2 connect to B. And channel 2 also you must be connect the route for that scope probe. Then how can we measure the difference?
Use the math function.
What can we do?
Use the math function.
Exactly. That one, I don't know for the handout today, you can see that or not, but I believe they will. They telling you, connect scope channel 1 into point A, channel 2 to be point B. The voltage difference between VAB means VA minus VB. Then you can tell the scope will be doing for you. Price will be pressed on the math function. Okay? On the math function. then select channel 1 minus channel 2, and they will be given you the answer. Or when you want to measure the signal with too much noise, normally the signal is too small, you get a lot of noise. If you press auto set measure, they given the value is not correct. The thing is noise. So in case they get too much noise and you want to measure, what can we do? Using what?
Require.
You use,
You use acquire and average.
now. You try to using the average, right? However, on this scope, I don't think they can do that. The signal was too much noisy. And if you press auto set measure, they measure, but they give a wrong answer. To get the correct answer, what can we do? Who already working on this one? You're able to tell me. Otherwise, you get an interview in a company if you're not lucky to see me. I ask the question and I can tell you go back to school. Okay, if you don't know, I telling you. We'll teach you, we will help you to do it. But you have to using the cursor. That will be in the oscilloscope. You're using the cursor to measure on the top, measure on the valley to get the average. Okay? So I will be stopped today and we'll be continuing on next meeting. The thing is we don't have a much lecture. I try to get through as much as we can so I get more time to helping you to really understand when you're working on left phone, AC1 and AC2. But a certain block, not everything. Okay? So, any question? Otherwise, we'll be done for today.
No questions. I appreciate everything I learned today. Thank you.
Yeah, I try to help you. Okay? So, guarantee you can do the technician job. You understand, I've been running this program for over 37 years. Every time, a lot of different. I see what your technician not quite understand. If you not understand how to do the lab, sooner or later you will be quit. I don't want that. Okay? So this is a handout telling you can do anything you need. Okay. And also they explain to you on the generator. Okay. So if no more questions, yeah.
I could read that handout so I could prepare for tomorrow's lab.
Yeah, that's what needed.
Will do for homework.
Okay. And also you understand tomorrow up there, I can install on this one. This is the program. We put on desktop on each computer. They say You want to set each window to design channel. Enter number 1. They're telling you, press auto set, then measure. Number 2, press top button, then select the source. Press each window to design channel. You see that? You
Yes,
follow that, you can do everything you need.
that's excellent.
Yeah.
I'm
How to set
excited.
a scope probe to match your probe. How to set coupling AC/DC. Set measurement. Yêu cầu cursor to measure time. Yêu cursor to measure the voltage. Okay. And how to measure the signal width down round. That means measure from A to B, for example. Okay. I will be adding more things later. But tomorrow I up there, I will be upload on after for this function, for this menu here into each computer. You don't have to open your handout. You just click on that, they're telling you step by step how to do it. Okay? More you do, you will get along with that. Okay, so it stops here. Okay, good night, everyone.
Nice.
Good night.
Good night.
And,
Good night.